So in the previous online class, we have talked about the trigonometric ratios with respect to subspecific angles. And now in this class, we will do a theorem, and from that theorem we will obtain some relations between the trigonometric ratios with respect to complementary angles. Alright? So now let us move on to that theorem. So the theorem states like this: if theta is an acute angle, then we have the following relations. Alright? The first relation is sine of 90 minus theta is equal to cos of theta, and cos of 90 minus theta is equal to sin theta. Tan of 90 degree minus theta is equal to cot theta. Cot of 90 degree minus theta is tan of theta. And we have the last relation, which are sec of 90 degree minus theta is equal to cosec theta, and cosec of 90 degree minus theta is sec of theta. So now we go to the proof of this theorem. Alright? So first of all, we will consider a right angle triangle. So let me draw that right angle triangle. So we'll consider this angle to be 90 degree. Alright? So let me just denote this right angle triangle by A, B, C. Now let us consider this angle to be theta, or you can consider this angle to be theta. Alright? It's the same thing. So let me just consider this one. Angle ACB to be theta. So let us write. Let us consider a right angle triangle ABC, and let angle ACB is equal to theta. Alright? Then this angle CAB, we find out this angle. Let me first denote it by X. Then angle CAB is equal to 90 degree minus theta. Why do we have angle CAB to be 90 degree minus theta? Because according to angles of property of a triangle, if we add all the three angles of a triangle, it should be equal to 180 degree. Alright? So that means if we add X, theta and 90 degree, we should get the sum to be 180 degree. Alright? So we want X, right? So we want to know what is the value of this angle. So I will just subtract theta and 90 degree on both sides. So if we subtract theta and 90 degree on both sides, theta and minus theta will get cancelled, 90 degree and minus 90 degree will get cancelled. So we are left only with X, and on the right side we have minus theta minus 90 degree. So we can simplify the right side. So 180 minus 90 degree, you get only 90 degree minus theta. So that's why X we get this angle to be 90 degree minus theta. Now we can clearly see that if you add these two angles, 90 minus theta and theta, you will get to be, the angle will turn out to be 90 degree. Alright, so these are complementary angles, because two angles are said to be complementary if their sum is 90 degree. Alright, so now we will see some relations of the trigonometric ratios with respect to these complementary angles. Alright, so first of all, let me consider with respect to angle theta. So let me just write with respect to theta. So with respect to theta, what are the base and the perpendicular of this triangle, right? The perpendicular is that side which is opposite to that angle which we are considering. So if we consider theta, that means this side, alright, AB is the side which is opposite to this angle, theta. So that means AB must be the perpendicular. So with respect to theta, we have AB is equal to the perpendicular. I just denote it by P, perpendicular. And this will be the base. BC will be the base. BC will be the base. Now, the hypotenuse will always remain the same. Whether you are considering with respect to this angle or with respect to this angle, the hypotenuse will always remain the same. Because the hypotenuse is the side which is opposite to the right angle. And we clearly see that this is the right angle and this is the side which is opposite to this right angle. So that means this is the hypotenuse. So if you consider with respect to this angle or with respect to this angle, the hypotenuse will always be the same. So I won't write down hypotenuse. Now, with respect to theta, we have perpendicular to be AB and base to be BC. Alright, so now let us write down the trigonometric ratios with respect to this angle theta. Sine of theta is perpendicular by hypotenuse, so that means sine of theta is perpendicular by hypotenuse. Hypotenuse is this side, AC, so we have AB by AC. Cos theta is base by hypotenuse, so the base is BC and hypotenuse is AC, and we have tan theta to be perpendicular by base, so perpendicular is AB and base is BC, so we have AB by BC. And cosec theta is the inverse of sine, alright, the reciprocal of sine, so we have AC by AB. Sec theta is the reciprocal of cos, so it's AC by BC. And cot theta is the reciprocal of tan theta, so we have BC by AB. Now we'll consider with respect to this angle 90 minus theta, so let's write with respect to 90 degree minus theta. What are the base and the perpendicular? Since this side is the side which is opposite to this angle 90 minus theta, so this side must be the perpendicular. So BC is the perpendicular and the base must be AB. AB is the base. And the hypotenuse, remember, always remains the same, it is AC. Alright, so let us find the 6 trigonometric ratios. Let me continue on that side. So we have sine of 90 minus theta is perpendicular by hypotenuse, so perpendicular is BC and the hypotenuse is AC. Cos of 90 minus theta is base by hypotenuse, so the base is AB and the hypotenuse is AC. Tan of 90 minus theta, we all know that it's perpendicular by base, so perpendicular is BC and the base is AB. And cosec of 90 minus theta is the reciprocal of sine, so it will be AC by BC. So sec of 90 minus theta is the reciprocal of cos, so it will be AC by AB. And last one, cot of 90 minus theta is the reciprocal of tan, so it will be AB by BC. So let me denote this by equation, by relation 1. Let me denote, or by relation 2 I mean, and I denote this one by relation 1. So if you look at these two relations, we can conclude that sin 90 minus theta is equal to BC by AC, and from here we see that BC by AC is cos theta. So that means sin 90 minus theta is equal to cos theta. So that means what? You just write down from 1 and 2. From 1 and 2, sine of 90 minus theta is equal to cos theta. Alright, so we'll see for cos of 90 minus theta. Cos 90 minus theta, we see that from this side it is AB by AC. Alright, and from the right side we see that AB by AC is AB by AC is sin theta. So that means cos of 90 minus theta is equal to sin theta. So we'll look at the other relations. I'll continue from here. So now we'll look at tan of 90 minus theta. Now tan of 90 minus theta, we see that it is BC by AB. Now we look from here, what is BC by AB? It is cot theta. So that means tan of 90 minus theta must be equal to cot theta. So we have tan 90 minus theta is equal to cot theta, and cot 90 minus theta is equal to, from here we see that cot of 90 minus theta is AB by BC, and from here we see that AB by BC is tan of theta. So that means cot of 90 minus theta is equal to tan of theta. So we have two more relations, which are cosec of 90 minus theta. From this side we see that cosec of 90 minus theta is AC by BC, and from this side we see that AC by BC is equal to sec theta. That means cosec of 90 minus theta must be equal to sec theta. And we have the last relation, which is sec of 90 minus theta. So sec of 90 minus theta is AC by AB, and we clearly see that from this side AC by AB is cosec theta. That means sec of 90 minus theta must be equal to cosec theta. And hence we have proved the 6 trigonometric relations, alright, between complementary angles. Now we will use these relations, alright, to solve some problems from the next exercise. And we'll solve one problem from question number 1, which asks us to evaluate this quantity sine of 10 degree by cos of 80 degrees. So to solve this problem, we either try to change the expression of this angle, or we try to change the expression of this angle. But we will not change both the expressions, alright? I will explain to you later. So first of all, we try to exchange the expression of this angle, which is 10 degree. Let me just copy down first. Remember, 10 degree can be changed into any expression. For example, 10 degree can be written as 45 minus 35. Alright, so you'll get 10 degree. But actually, if you change into this expression, you won't be able to use the relations which we have just done. Because the relations which we have just done, the angles are expressed only in this form, 90 minus theta. So that means 10 degree we have to express in this form, 90 minus some angle. Alright, so that is expressed in this form. 10 degree can be written as 90 minus 80 degree. Alright, so now since we have expressed in this form, and according to the relations which we have just done, sin 90 minus theta is equal to what? Is equal to cos of theta. So that means sin of 90 minus 80 must be equal to cos of 80. Because in this case theta is 80 degree. So we have cos of 80 degree by cos of 80 degree. Even though we don't know the value of cos 80, but still we see that cos 80, it has some value, alright? So it will be the same. This cos 80 will have one value. This cos 80 also will have one value, and they are the same. So that means we can cancel out. So we'll have only one. Alright, so this is the required answer. Now we move on to the next question. which is question number 7. And from question number 7, we do the first question. And the question tells us that we have to prove this quantity tan 10 degree into tan 25 degree into tan 45 degree into tan 85 degree into tan 65 degree into tan 80 degree. Alright, so now we have to prove that this expression is equal to 1. So let us start from the left hand side. So we have the left hand side to be tan of 10 degree into tan of 25 degree into tan of 45 degree into tan of 65 degree into tan of 80 degree. So now we clearly know that tan of 45 degree according to the trigonometric ratio with respect to some specific angles which we have done in the last class is 1, right? The value of tan 45 degree is 1. So we can just write down tan 10 degree into tan 25 degree into 1 into tan of 65 degree into tan of 80 degree. So now I'll express these two angles in this form, 90 minus theta. Alright, so 10 degree can be written as 90 minus 80 degree, and 25 degree can be written as 90 minus 65 degree. And so if you multiply 1 to this whole thing, you get the same thing. And these two terms I leave the same. Because we want to get the value of the right hand side, which is 1. So I'll just change these two values. I'll explain to you later. Because if we use this relation, which we have just done, tan of 90 minus theta. Tan of 90 minus theta, we all know that it's cot of theta. So that means tan of 90 minus 80, according to this relation, must be cot of 80 degree. And tan of 90 minus 65 must be cot of 65 degree. So we need these two to be the same. Tan 65 times tan 80 degree. Now, because I want to get the value of the right hand side, which is 1, so that means we must cancel out these two terms, alright? So how do we cancel out these terms? Since we know that from this relation, tan theta is equal to 1 by cot theta, so we just multiply cot theta on both sides. We'll get tan theta into cot theta. And if you multiply cot theta on the right side, we'll get cot theta into cot theta, alright? We can cancel them out. So you'll have only 1. So that means we get tan theta into cot theta is equal to 1. So now we see that cot 65 and tan 65 will cancel out each other and we'll get 1 according to this relation, alright? Remember, this theta should be the same angle. And since here we have the same angle, which is 65 degree, so that means cot of 65 into tan of 65 would be 1. So we have cot 80 degree into 1 into tan of 80 degree. And so we have only cot of 80 degree into tan of 80 degree. Now we can use again the same relation, tan theta into cot theta is equal to 1. Since these angles are the same, so that means we can use this relation, alright? So cot theta into tan theta will get us 1, which is equal to the right hand side. And this is the proof, alright? So I'll end here today for this class, and on the next class we'll move on to a new chapter, and I hope that you've gained a lot of benefit from this small lecture. Thank you.